Hello students, this is Miss Dalton, and this video is going to go over the exponential growth and decay formulas that we're going to use for this unit. Okay, you're going to see some word problems for this section, and the word problems are all going to be dealing with exponential growth and decay. And so what you need to realize is that exponential growth is going to be an increase in value. It's kind of what we're experiencing right now with this coronavirus. We're experiencing exponential growth in the virus attacking people. The exponential decay is going to be a decrease in value. So we see that a lot, like when we're talking about when you buy a car, your car depreciates. Depreciates means that it loses its value at an exponential rate. There are three primary formulas that we're going to use for exponential growth and decay, and they are simple interest, compound interest, and then continuously compounded interest. You're going to see those words in the word problem, so you're going to know exactly which formula to use if you pay attention to those words. Okay, the first formula is simple interest. Simple interest means that the value is added or subtracted one time over a time period. So a lot of the times you'll see simple interest, like in a checking account, it's just added one time, and you'll see that again in the word problem. It'll say it's simple interest, and really honestly, if it doesn't say anything about it being compounded, then you know it is a simple interest problem. Okay, the formula for simple interest, it is a growth equation, and it's A equals P times 1 plus or minus R to the T power. So what do each of these variables stand for? So the first one is principal. Principal is the P, and that is your starting value. R is going to be the rate of change, and it's going to be as a decimal or a fraction. Honestly, we mostly use it as a decimal, so remember you're going to be given a rate as a percent, and so you're going to have to change that to a decimal. T is time, so whether that be in years or months, T is always going to be your time, and that's going to be your exponent. And then A is just the total amount accumulated. A lot of the times I'll say A stands for after. So A is how much it is worth after the interest has been added. And then P is the before, so it's the present value. So if you think about those letters meaning that, present versus after, you'll remember those a little bit better. All right, the second formula is called compound interest. What that means is that the value is added multiple times per time period, and interest is paid on any previous interest accumulated. So you'll see that sometimes they might say, like, this savings account that you have, it's compounded monthly. What that means is that they add the interest rate every month, but that interest rate is being added on top of previous interest, or it's being calculated also on previous interest. Again, you'll see this in the word problem. It'll say compounded blank. What the formula is that it looks very similar to the simple interest one, but we are taking into consideration the N, which N is the compounded amount. A equals P times 1 plus R divided by N, all of that raised up to the NT power. Okay, so let's see what each of these variables stand for. So the P is just like in simple interest. P is your principal, or your starting value, or sometimes we think of it as the present value. R is the interest rate, so that's also going to be the percent, but you're going to change that percent to a fraction or decimal. T stands for the same thing as it did for simple interest. T is your time. And then A is the same thing as simple interest, where A is the after amount, which is after the interest has been added. Okay, but now we have this N. N is the number of times the interest is compounded per time period. So let's look at this next slide to see the different values of N. All right, so the different values of n. If it says it is compounded annually, then the n is just going to be 1. What that means is the interest is only added one time per year. It's added annually, so the n would just be 1. Semi-annually means it's added twice. It's added in June and then again at the end of the year. So semi-annually, your n would be twice, so 2. Quarterly, think about the how many quarters you have in a dollar. There's 4. Well, that's how many quarters we have in a year, and now that kind of makes sense to you now that we've moved to a grading period that's in quarters. We have 4 quarters, so that means n is 4. If it says it's compounded monthly, that n is going to be 12. Again, we have 12 months in a year, so the n is 12. If it says weekly, compounded weekly, then that's going to be 52. There are 52 weeks in a year, so if it's compounded weekly, my n value is going to be 52. And then if it says daily, we have 365 days in a year, so our n is going to be equal to 365. Again, you're going to see this in the word problem. It'll tell you compounded blank, compounded monthly, compounded weekly. Therefore, you know you're using your compound interest formula, and then what it says after the compounded represents what your n value is. Okay, the last formula that we use, it's the continuously compounded interest or growth. What that means is that the value or amount has added value continuously. It's roughly every second. That means interest is paid over and over and over again, almost by second. It is paid on any previous interest accumulated. I call this the PERT formula. You'll see why. It's A equals P times E to the RT. Now, you haven't really seen that E value before, but E is just like pi. It represents a number. It's actually almost about 2.8. So the E is going to be a number. Now, there is a button on your calculator that you can use for that. Okay. Everything is, the letters represent what we've seen in the previous formulas. Your P is your principal or your starting value. E is the number E, so again, like I said, it's about 2.8-ish, and you're going to see that there's a button on your calculator that you can push. R is your rate of change, so it's going to be your principal, I'm sorry, not your principal, it's going to be the percent. You're going to have to change that to a decimal or a fraction. T is the time, just like previously, and then A is the after amount, or the total amount accumulated after the interest has been added. Okay, so that's it for this video. We wanted to kind of separate out the videos. We did one video with just the formulas, and that's this one. So now that you've got your formulas down, let's look at some examples, so you'll have to watch the next video to see the examples.